When carrying out biomechanics, there are many methods in order to collect our data for our numerical model. Obviously, different qualities of the method end up with better quality results. Therefore, many methods that are used with perhaps less advanced equipment will not be as accurate as new technological approaches. In this data collection, we'll be focusing on the vertical jump and a 20 meter sprint. For a vertical jump, we would ideally use force plates. This is where this force plate will measure the force created that pushes onto the floor when someone goes to jump, and it will take the reaction force of it, which will be the same as the person creating the force. Therefore, it would measure the distance, the peak power, and the distance that the person has rose vertically. Force plates can measure up to 1,000 measures per second, which gives that incredible detailed measurement of the vertical jump, where the results couldn't be more accurate. For the 20 meter sprint, ideally we would use timing gates. These are gates that measure the time after someone has run past it, meaning that we'll be able to see the change of time from each point very accurately as the reaction of them are very quick. So for our 20 meter sprint, we would have cones at 5, 10, 15 and 20 meters, and ideally we would have a timing gate at each every 5 meters. So this would give so all the timing gates would start at 0, then it would be a lot easier to calculate the time difference. When perhaps getting a 2D image, using more advanced software can use markers to make the image turn 3D, used mainly by Vicon cameras. This gives much more detailed images of the joints, which can have angular joints, angular motions, and other types of information. To create a 2D image in the first place, the setup of it has to be pretty much perfect. Factors that included in this could be the height of the camera, the field of view, and the settings of the camera have to be right, and the position is also incredibly important. For example, when performing a vertical jump, many factors need to be taken into account, and one of them is the field of view. This requires checking the distance of the camera to the performer, where the performer has to be in the whole image at all times, meaning that they need to increase the distance between the performer and the camera in order to get the whole shot. This is called the field of view. Ideally, when taking the data, the quality of the camera will provide more detailed data and perhaps less quality camera. This is because factors such as frame rate and shutter speed is crucial for collecting the best quality images and the best data. Firstly, some really good cameras can take around 1,000 shots per second, whereas less expensive cameras could only take around maybe even 30 shots per second. This is called the frame rate. If the camera has a higher frame rate, it can collect much more detailed images of perhaps an angle shot, where perhaps the data is being collected on the knee joint where someone is doing a vertical jump, and the higher frame rate will give much slower motion of that knee joint to give the analysts more knowledge of that joint. As well as needing a good frame rate, a good shutter speed is also very important. This is how quickly the camera shutters when taking the frame. This increases the quality of the image of each frame. So frame rate is the quantity of the shots, and the shutter speed is the quality of all the shots. A faster shutter speed means better quality images. However, fast shutter speed may have a good quality image. However, the quicker the shutter speed, the less light will be able to get into the camera. Therefore, the slower the shutter speed, the more light the image has. As a result of this, you need to balance out the shutter speed in order to get a good clear image, which also has light in it, which means high shutter speed does not always mean the image will be at its best. Also, in order to get the most accurate results from this data collection, the setup of the camera is one of the most important objectives to complete. Firstly, position of the camera needs to be taken into account. If perhaps someone is doing a 20 meter sprint, then the camera would be perpendicular to the runner around a 10 meter distance, where there is a Pythagoras 3-4-5 triangle called triangulation, where the field of view is shot, so there's a bit of distance as well. The camera position is also important as the camera would need to be even to the runner, where it's not facing up or down, it's facing straight forward towards the runner. Ideally, there's a tripod so the camera can easily pan whilst or still be in exactly the same position without it rolling or tilting, whilst the camera can be left, which it can turn left to right to track the runner. There can be huge misleadings if these aren't done correctly, such as perspective error. This is where the angle or the position of the camera does not give the correct results of something that they may be analysing. It will appear to look different than it actually is. Therefore, for example, if someone was running 20 metres and we wanted to find the angle of their legs where it moves, different positions on the camera will give it different angles. Therefore, it would ideally be measured parallel to the runner when it is measuring that angle, then perhaps at a more angular shot. That is why the position of the camera can really mislead information. Finally, there is a website called Dartfish, which is quite expensive, so ideally bigger sports clubs will use this, and you can put all your images and all your data into this website where it can measure angles, distances, and many other useful data analysis, which is ideally great to get good results and look at comparisons and that type of stuff. Obviously, to collect detailed and high quality pieces of information, it costs money and people just can't afford most of it. Therefore, the way we'd measure the 20-metre sprint and the vertical jump would be very different to the ideal version. Firstly, instead of using advanced force plates, we would use jump meters. This is where there's a flat mat that the person has to stand on while there's a string attached to it. Attached on the other side of the string, there was a Velcro strip that needs to be go around your waist tightly. Once that is around your waist tightly, you would then set the length of the string at 0 as the height of the person affects the length of the string. Once that is good, the person will then jump and the length of the string will be measured, hence the vertical jump will be measured. For the 20-metre sprint, instead of using timing gates, we would use our phones, and due to human reaction time, it's not going to be recorded at the exact time that the runner passed the cone at the 5, 10, 15, 20 metre point, and this is mainly to do with perspective error. Also, with using our phones, we will not have as high quality cameras, where we were not able to get as quick frame rate or as better quality shutter speed, so it will be slower shutter speed when taking digital images. For the 20-metre sprint, we would also be at that perpendicular angle, but with perspective error, the actual moment that the person running past the course cone would be different to the time the person collecting it thought it did. There would also be no tripod, meaning that the pan of the camera will be a bit wonky when a human is turning it, and if an angle needs to be measured, it might not give out the right information. Therefore, we collected results from taking a 20-metre sprint and vertical jump, and here we have the results of the velocity and acceleration of my performer and the group average of the 20-metre sprint. So as you can see, to start with, the group average, it took around 3.8 seconds to complete the 20-metre sprint, where they reached the highest amount of around 6.7 meters per second. And however, you can see my performer that he starts off pretty slow, where at around 3.5 seconds he was only around 5.8 meters per second, so he was much under average for that. However, from that till from the 5.8 to the 4.1 seconds, he increased his velocity a lot to around 9 meters per second. So you can see my performer got the highest velocity at one point. However, he wasn't very consistent with his velocity, as he started off pretty slow and he sped up quite quickly near the end. And this was different to the group average because it was they started off pretty quick, and near the end they finished around 3.8, and then my performer finished around 4.1. So they averaged a higher velocity, therefore they completed in less time. So you can see that my performer it shows that he does have, he can get high velocity or speed, but he may need to balance it out throughout the whole race and just try and increase it more consistently than perhaps just increasing it fast at the end. Therefore, to perhaps improve performers' velocity, he would need to go on runs, try and improve his fitness, try and improve his speed more consistently, as it shows on the graph that he is below group average on the time it takes for him to run 20 metres, as well as his velocity overall being lower than the group average, however reaching a higher peak velocity. So it shows that he can get the pace, but he needs to maybe get that pace from the beginning, then and then keep that pace until the end, instead of only running that fast in the last second of the race. You can also see the acceleration of my player and the group average, where my player starts to increase his acceleration to around 2.2 meters per second squared, then decelerates by quite a bit. However, he goes up to he accelerates incredibly up to around 6.01 meters per second squared when he decelerates to from 0.5. So it shows he can accelerate very quickly. However, from the first 2.7 seconds of it, he accelerated pretty slowly, which probably increased his time of the whole 20 meters. This is very different to the group average of acceleration, as in the first 1.2 seconds, the average acceleration went up very quickly to around 3 meters per second squared, to a lot quicker time than my player, but then it decelerated very quickly down to, well, not very quickly, but very slowly down to around 0.45 meters per second squared. Therefore, it accelerated quickly and then gradually decelerated, resulting in finishing in less time than my performer. So what my performer may be doing wrong is judging the acceleration wrongly, where he slightly increased it, then he decelerated and quickly accelerated after that. So yeah, you may need to increase that as well. Here we have the results of the full-on comparison between the group average, NBA elite player and better player. So as you can see, our performer took the longest time with around 4.1 seconds, with a group average around 3.7 seconds, the NBA player around 2.4 seconds, and the better player around 3.45 seconds. So you can see that the NBA player has a much quicker time than any of the other comparisons. That's mainly because they're a professional athlete and they are professionally trained to increase their speed and acceleration, so they all get a quicker time. However, for my group average and better player, they also have a quicker time than my performer. Therefore, reasons for this could be that my player is unfit or not eating the right diet. So there are different factors for my player being a lot slower than the rest. So my performer would need to increase their speed and acceleration, as this can play a huge part in basketball due to perhaps defending or starting a counter attack, which can really benefit the team. My performer would need to try and get to at least a group average, and then try and work from there to get even quicker. So we've looked at the results for the 20 meter sprint, and now we have the results of the vertical jump of my performer, the better performer, and the NBA elite player. So you can see